the more we practice some of these problems in slope-intercept form, the quicker and easier they're going to be, because again, you'll notice the same routine over and over and over again. And one of the things you'll also notice is the worse and trickier the numbers can be sometimes the easier they're going to be. We're going to look at two examples right now. Sometimes the easier the numbers to get, the more confusing they can be. Start at the b, my y-intercept. mx plus b, -8. Even though it's a large negative number, 2, 3, 4, 5, 6, 7, 8, boom, I'm ready to start. There's my starting point. Let's look at the graph. Well, because my m, -2/7, remember we just discussed when you have a negative fraction, we can put it in the top, we can put it in the bottom, we just can't put them both. It's probably best, get in the habit of putting it in the numerator. You're going to find out later when we have to do some operations. The last thing you ever really want to do is mess with the denominator fractions when we need common denominators. Just toss them in the top, keep it easy on us, but either one would work. If I have a rise of -2, that means go down 2 units. If I have a run of 7, that means go right 7. There's my graph. Done. Even though those look horrible numbers, the last thing we ever want to do, sometimes it'll be tempting, oh, 2/7, let me punch a new calculator. 0.28, blah, blah, blah. Horrible decimal. We do not want these. In fact, even though we can turn that into a decimal on a calculator easily, decimals are awful for us. We need it. We need it to be a fraction. If it's not a fraction, on that other problem, we actually had to make it a fraction by putting it over 1. Well, let's look at our next example. Y equals x. This is still in the form mx plus b, but when things are missing, sometimes they get trickier. This would be a nice one at the table. We'll do that here in a minute. What am I adding that I'm not really adding? That's going to be a 0, because remember, x plus 0 is still x. Anything plus 0 is itself. What's my m? What's my leading coefficient? Well, it would be a 1, right? That missing 1 in front. 1 times x is still x. X plus 0 is still x. When we don't have those there, it's almost like we have to make up, and it's going to even get worse. Where do I start this graph? Well, b, my y-intercept, at 0. It actually goes through the origin, which makes sense. The origin, ordered pair, 0, 0. Look, that's when x equals y. Well, now look at my slope. Rise over run. If I have an m equals 1, I don't even have a fraction. It's even better back here when I had a negative, horrible 0.28 something awful. Here I don't even have a fraction. Well, how do I make it a fraction? Put it over 1. Remember that if I have 1 over 1, from that 0 point, rise 1, run 1. Rise 1, run 1. Look at that ordered pair. There's my graph. And look at these ordered pairs, because that makes a lot of sense. Ordered pair 1, 1. X equals y. Ordered pair 2, 2. We could have done a table for this graph without even really thinking about it, because x equaled y, in every ordered pair, I have the same x as I do y. You'll find out later, this is what's called the identity function. It comes up with some of our inverses, and it makes a perfect 45-degree angle. It's very friendly when we look at our unit circle. A lot of things that come up in later classes, but the problem I want to do right now is that sometimes, even when we have nastier fractions and signs, a lot of times those are a lot easier than when we don't have numbers at all, because it's almost like we have to make them up. We have to recognize what are my missing numbers. But either way, it's still graphing mx plus b.